So we asked Mr. Oscar, as the head of the physics department, to come and engage with you in a small debate concerning natural sciences, specifically physics, as we're taking it in the ToK subject. The entire idea, Mr. Oscar, came about from when we were listening to a debate by Krauss, the physicist, and he was saying that physics cannot prove anything right to absolute certainty, but it can prove anything wrong to absolute certainty. We found this paradoxical because the same method and mentality you use to prove something wrong, to prove something right, you use it to prove something wrong. But students were asked to find an example of one instance where something was accepted, rejected, then accepted again. They failed to do so. And this is where we started thinking about the topic and what Krauss was saying, and we wanted to have your opinion about it.
Okay, so when we speak about the first chapter, if you're speaking about now what we teach in physics in general, not here at school, everywhere in general, we begin by teaching about the uncertainties in measurements. Before speaking about uncertainties in measurements, we have to be aware that in order to perform a measurement, which is the basic of the scientific method, I don't like to call it the scientific method, because we don't have one, but this is the one that was transmitted all along. So the first thing that we do is we use our senses. We use our senses, and our senses are already limited. So let me give you an example so that you understand. If you're looking now at a star that's far away, you look at the light, you say, wow, it's a wonderful star. So what sense are you using?
Science.
Vision, check. But in reality, the star might have died millions of years ago. But what you're receiving now is the light of the star. So before speaking about the uncertainties in the measurements, we already have an uncertainty in the way we perceive the world. Because we perceive the world through our five senses that do not give us really a full account of what's happening around us. This is one thing. So we cannot measure something with absolute certainty or prove something with absolute certainty. I agree totally about this. We cannot. Beginning by the human error that we call the random error. Before the random error, I spoke already about the five senses that precede the random error. So I may use my vision, but I may use it in a way that's improper, without looking properly. You know, I hope you were told, for example, about how to perform an appropriate measurement, to look horizontally, etc. So this is obvious for me. We always have a place for uncertainty. Even Richard Feynman, who is, I spoke a little bit about it maybe in the class, who is the father of nanotechnology, when he explains physics, he said, I can never prove anything with absolute certainty. This is Richard Feynman. And I'm concerning about something that, can you restate it exactly how you said it, that's proven wrong and right at the same time, something like this?
No, that he was trying to say that if you, physics cannot prove anything right to absolute certainty, as you just noted, but it can prove anything wrong to absolute certainty. And we wanted to experiment with it and try and find an instance where we had a theory that was accepted, rejected, and then accepted. Because if it was then accepted, then he is wrong.
So this is the idea. I have some examples in mind about it. I'm not a philosopher, so I cannot really build on the word that he used. But let's take Newton's second law. Newton's second law was taken as correct at the level of the macroscopic world. Macroscopic world, like you, me, not when we're dealing with the subatomic world and the microscopic world. Physics at the particle level. They discovered that particles at this level do not follow at all Newton's second law. So there was a first debate in the scientific community, what were we doing? I mean, we were taking Newton's second law for granted. So Newton's second law was shown to be wrong. But then there was this consensus that Newton's second law can be taken to be correct at the macroscopic level, while at the quantum world we need to adapt Newton's second law when you're studying the speed of the particles that are coming close to the speed of light, because it's not applicable anymore. I think this is an example of something that was accepted and rejected and then taken again or modified a little bit to suit the needs. You can take another example also now. I think you studied it in chemistry and you're speaking about it in physics also, about the models of the atom. When we started Thomson's model, it was this like this type of muffin with the seeds inside, where the electrons were distributed evenly, even with the positive charges. And then what happens? It was completely rejected after the famous experiment of Rutherford. In fact, it was the experiment performed by two students of Rutherford, Geiger and Marsden, but he was the one who was supervising the experiment. That showed that the model, in fact, that showed the emergence of a new model of an atom, which is you have the core, that is the nucleus, and then around it you have empty space. And till now, we are still modifying the model of the atom. This is another example about something that was considered to be correct, and then taken to be wrong, and then adapted again, a third example before you can begin interfering. It's not really an example, because till now it wasn't really proved wrong, completely wrong or completely right, but it's interesting to ponder on. There is a physicist that's called Higgs. I don't remember the first name. You may have heard about it when, if you heard about the God's particle, the Higgs boson, that we're explaining in IQ now when you're talking about particle physics. So Higgs, in 1965, in the absence of any really appropriate technology, said that in order to explain certain scientific phenomena that are happening at the subatomic level, stipulated the existence of a particle that he called the Higgs boson in 1965, nearly, if I'm not mistaken. He waited till 2012 while using the particle accelerator of CERN, the very famous particle accelerator of CERN, to prove the existence of a Higgs-like particle. He was 82 years old. He started crying after they made the discovery. And he speaks about the participation. He speaks about something that's called the Higgs field, that gives all the subatomic particles their masses. But till now, it's taken for granted. Why? Because he's taken as a reference in the scientific community. I'm sure that later on they may even find it wrong, and they may even suggest amendments or changes. So I don't know if this is fitting what you talked about, Mr. Roger. So now you can begin interfering or saying your ideas.
Well, regarding the last thing you mentioned, Higgs boson, which was proved at CERN, which was found at CERN. Just the year before that, in September 2011, in CERN,
The speed of light.
Yeah, they found a particle traveling faster than the speed of light.
No. In fact, what happened is that, this made a whole mess in the scientific community. So we found something traveling faster than the speed of light. So everything that Einstein was talking about is wrong. Because in general relativity of Einstein, one essential postulate is that the maximum speed that a subatomic particle can reach is the speed of light. Okay? And then 2-3 years later, there was a whole debate in the scientific community, and then 2-3 years later, they re-evaluated things and they discovered that really the CERN particle accelerator was not well calibrated.
Exactly.
So they repeated the experiment and they noticed that no, it wasn't moving faster than the speed of light. This is to answer your question, yes?
So you gave us examples where there were things that were proven right, then wrong, then right, then wrong, right? So that means science, like physics in general, can't prove that something's completely wrong.
I don't like the word prove, really. And then we didn't speak about proven right or proven wrong. We spoke about absolute right and absolute wrong.
Okay, so
physics, like all sciences, is evolving. There's a continuous state of, you can say, improvement, how do I say, expansion. Why? Because like all sciences, I'm going to be a little bit philosophical here. All sciences, or if our first approach towards sciences is that they are completely fixed or static, so they emit something and that's it, then we are in the wrong way to approach sciences. Sciences describe what happens in the universe and try to explain it, whether biochem. Sciences, unlike what we don't ever invent anything. Everything is already here. Energy is already here when Einstein spoke about energy. It's here. Einstein tried to come with an explanation that can fit in our framework of the five senses for us to understand what energy is through equations. And Einstein wrote it through equations. An artist will write it in another way. Take a scenery, for example. Give it to a physicist. Let's say droplets and leaves. A physicist, when looking at it, is going to begin thinking the mass of the water droplet is bending the leaves. An artist will look at it, is going to begin saying, wow, look at these wonderful shapes in the leaves and the tree, etc., etc. And then the chemist is going to come and is going to, oh, the structure of the water molecules here is very interesting. And the structure of the molecules of the leaf is also interesting. An English teacher is going to come and is going, oh, I'm going to write a poem to my bien-aimé, but I'm sitting under this tree. So everyone is going to perceive it in a way that is different. Because we do not have absolute certainty about anything. And this is what's so wonderful. It's so enriching to have all these perspectives from different angles. So, not that something is proven right. Something is taken to be right at this period of time. And then if it remains right, nothing comes to oppose it, why not? But then if something comes to oppose it, also why not?
So you do not believe that something is proven? Like you don't agree with the physicist that said that physics can prove that something is completely wrong. You don't agree with that?
When Mr. Rogers spoke to me, I felt I need to agree with him, although I do not really agree.
No,
I don't
feel free.
No, nothing is absolute. Nothing is absolute. Even if you look at religion, where everything is supposed to be absolute truth, even through the ages, everything evolved with religion. I believe that there is something absolute that we cannot cater to with our five senses because they are limited. And you cannot cater to something unlimited with your five senses that are limited. But then you can cater to something that's relative. Physics is a relative science, chemistry is all sciences are relative. But we're lucky that they are here, in fact, because they improve our understanding of the world.
How could we rely on physics and chemistry and biology, even though it has, as you have mentioned, a great deal of uncertainty and evolvement and change? So how can people in their daily lives, or even scientists, rely on these formulas and equations, theories and hypotheses formulated and accepted?
Yeah. First, you have to understand what we mean by the word uncertainty. May I take this question and then I'm confused? The word uncertainty does not mean, although it is translated by error, but error doesn't mean that something is wrong. So I look at your foot, for example, and I make a blunt estimation. I will say Christopher is wearing 42, for example, while you are wearing 41. It's something that's really close to what you are wearing. So I cannot say it's wrong in terms of really wrong. So what I have to do is to improve the way I'm measuring. And this is why the thrive of science everywhere is to do what? To improve, exactly, to improve the measurement tools. But see, this is a nice paradox at the same time. However you improve, or you can improve as much as you want the measurement tools, but the one behind the measurement tools, which is the human being, is always having limited, some things that are limited. But that's a nice paradox. So this is why, okay, if you think that when we say uncertainty, we're saying wrong, I can understand your frustration. But no, it doesn't mean wrong. It does not mean wrong at all. It means we're observing something we're trying to explain it in a certain way, and we try to get as close as possible. And here we go to what's called modeling in sciences. I'm speaking a lot. I need to give you more time to very question. Yeah.
Yeah. You said that you believe that there is something that can be proven, or there is something absolutely certain in the world, but we will never be capable of understanding.
Yeah.
How can you say that, but then not believe that there's things that we can prove absolutely false?
Because no, we're not talking about. I'm talking about the way to prove it. And I said I believe that there's something that is completely certain. Huh? If we speak about philosophy, if we speak, let's say, I teach yoga, I refer to yoga now. In yoga, they say that behind everything you have this over-permeating energy everywhere. It's everywhere. It's really strange because it fits a little bit what Higgs was saying, this Higgs field that's everywhere. That's the essence of everything. This is for me an absolute truth. Energy is everywhere, you cannot deny it. What's relative is that energy manifests itself under different forms. And this manifestation of energy under something that I can perceive through my five senses that allows the sciences to exist. Because then I can see them or hear them, you see? So what I said about absolute is a belief of mine. It may appear to be true or no, I have no idea. But I really believe in it.
So for something to be considered absolute truth, it's something that you would accept yourself on your own terms.
Yeah.
But then why don't you accept anything to be absolutely false?
It's not I didn't accept the idea that we can prove something absolute. I know the word prove is the word that's bothering me.
But there is something that is absolutely false. We won't be able to.
With respect to the opinion of someone else, yes, probably. Everything exists in pair. According to physics, Newton's third law, action-reaction. At the subatomic level, matter, antimatter, you can explain the presence of something by referring to its opposite. So if you follow the same logic, when I say something is absolutely wrong exists, or true exists, maybe there's something countering it that's absolutely wrong.
But going back to all of the examples you gave in the beginning, where you were giving examples of theories that have been accepted, refuted, and then accepted but modified. They weren't completely accepted in the way that they were originally presented. So could you say, for example, express that you believe that whatever was brushed aside or ignored or modified, that can be considered false to the extent in which we can understand it?
That can be considered false. Yeah, for example, I totally agree with, understood. If you take Thomson's model, for example, we cannot say in any sense that it has, but still it has a degree of truth.
What does?
It contains positive charges, it contains negative charges.
But in order for you to be able to accept that it is false, you would be able to say that we are moving one step closer to reaching.
But you see, when you're saying absolute, even when you say absolute or relative, you need a framework, you need a reference. We need a reference. We cannot lie to ourselves. Whatever we talk about, we need a reference. So when they said Thomson is completely wrong, what was the reference? They were not speaking about the fact that the atom contains positive and negative charges. They were speaking about the fact that these positive charges are located in a dense place that's called the nucleus. So they agreed somehow to Thomson somehow, but they disagreed about something else. This is a game of life, and I find this really thrilling. Yes?
Sir, if you say that they found out that there are positive charges and negative charges in sometimes aren't they absolutely certain that there is a positive charge and negative charge? Then how do you say that science cannot prove something to be absolutely certain?
Here you have to really understand the way science functions. So the first idea we have about science is that in science, we observe, we measure data. This is what's spread in the book about the scientific methods. I will ask you a question in order to maybe to help you answer this. Why did they call them positive and negative? Why didn't they call it Zachem, for example, and Sayed, for example? Why?
Because they were opposite.
Because they need a reference. So they decided to call them positive and negative. They could have called them something else. So already in the terminology we have a problem already. You see? Already in the terminology we have a problem. So he noticed that he had two types of charges that are behaving in a certain way, check, in a way that was opposite, certain properties that were completely opposite. So he decided to name them by something opposite. He could have named them something else. Now we're taking them for granted. مثلا نقول إذا واحد عم يتصرف غلط بنقول he's negative. And someone is behaving in a good way, we say he's behaving in a positive way. It's weird, huh? As a concept.
As the model of the atom changes through time, weren't they doing that? Weren't they making the model simpler? Weren't they like making this estimation when you measure?
Yeah.
You try to become more precise.
So not simple. That's more precise.
More precise.
A model always begins as much as possible in a simple way and tries to fit more and more reality. So here, this is a big question in sciences. Will a model be able to fit reality completely? It's an unbelievable question, because don't forget that people who came with the model of the atom they never saw actually an atom. At least to think also. You got what I'm trying to tell you? So let's get rid of this idea that science is giving answers that are in a can, خلاص معلبين, and it's over, and this is the answer. It's not true. It's not true. For one simple reason, if you forget everything we talked about, life itself is in a state of expansion. It is the only thing in life that's always permanent. There's only one truth in life. Only one truth. That everything is not permanent. Do you get what I said? The only truth that is true in life is that everything is not permanent. Everything in a state of complete change. So we are observers, we are observing this change. We are observing this change. And the main challenge that we are always facing is what? How we can interpret this change. And through observation, through measurements, through whatever. That's شغل زيرو. If you go in the Western world, and you know this very scientific world, you go to the more Eastern world, like Japan, like India, you know, they have a completely different way to perceive the world. A completely different way to perceive the world. They don't ever think, not now, now science is very well spread, but before, they had a way to perceive the world that's more intuitive, correct? That's more creative. The DNA, you know, shape of the DNA. The guy did not calculate it and then do it. It was like a eureka. Wow, I got it after so many explanations. The most important decision in life that you take, one of the most important decisions in life, that you will take later on, is what? Later on.
Deciding what's true.
When you're going to get married, correct or no? All these dreams about the soulmate. It's a very important decision. And how do you take this decision? Using what?
Senses.
What? Intuition. Very rare are the people who are going to marry based on intellect. أكيد بيحسبوا معهم مصاري هالقد and all of this and all of this. Yeah, fine, but this is a major decision taken in life that's taken based on what? Intuition. And you have always not to forget the intuitive aspect of science.
Sir, you said that there is only one truth, that everything changes in life and everything. And then how come you say there are, let's say when you said that Einstein, figured out an equation for energy, you said that there was energy, he discovered it. So it was there before. How come you say everything changes if there are things that do not change?
The manifestation of energy, when I said we can perceive energy through its manifestations. It's a belief of mine that there's something that's a field. You know, you have in physics the 4 major fields. If you don't know, I'll tell you what they are. You have the nuclear field, with the strong force and the weak force. Okay? And you have the gravitational and the electromagnetic one. These 4 fields. When Hawkins started speaking, did you see the movie Theory of Everything or no?
Yeah.
So what is theory of everything? Behind these 4 fields, there is one thing, and everything else is coming from this. So this is the belief of Hawkins, and his dream was to be able to come with a synthesis of all formulas, coming with one formula that would explain everything else, because he believed that everything we're studying originates from a single place, or whatever he calls it. I don't know. You see, so it's a belief of mine that there's this space of energy, and then we study its manifestation.
Another interesting thing that probably we can shed light on is the fact that science, natural sciences, physics, chemistry, and biology, to a certain extent are motivated by economic, political, social standards and endeavors. For example, we are going to be studying about B.C. Miller, who after 25 years of experimentation, reaching to the same conclusion using the scientific method, he was able to prove some of Einstein's theory. To be exactly which theory, it will take me a while, but he tried to prove some of his theories wrong. And when he presented them to the scientific community, it was immediately rejected. And his career as a physicist, an experimental physicist, was completely kind of washed away. And we even tried to search it on Google, and very few information exists on what actually he said and did. It was all based on the fact that he is Einstein, and you cannot get close to him. So there are, as if, kind of political, economic, social bias underlying even natural sciences are supposed to be very objective.
I totally, again we come to define what is objectivity. I totally agree with what you're saying. If you research a little bit Einstein's life, he was not the first one to speak about relativity, but still because of his PR, he was able somehow to get his things to be published. This is very interesting also to know. Let's not forget that scientists are human beings, and at the same time they live the stories of human beings. You have competition, you have jealousy, you have lots of things that are occurring. I totally agree about this. If we take the example of genetically modified organism now, genetically modified food now is bringing the USA a minimum of $70 billion pure profit per year. Some major corporations in the USA. Any scientist who is publishing an article against genetically modified food, at some extent, some scientists are being expelled from universities with no explanations. So I totally agree that this factor unfortunately exists in science, but where doesn't it exist? So it's our role, I think, especially as students who are going to become young adults, to be able to discern, to give really a value for ethics and science. I think this is our only weapon about the lack of objectivity in science. Yes?
So considering that science is inductive and that naturally the human being tends to evolve or his thoughts or his observations to facilitate it, how close to certainty or factuality is the science we know, or the science we know and the science we study, which is maybe the most reliable source of knowledge?
Maybe we know how close, we're very far away in fact. Maybe we know how much from the universe, 1%, less. So it gives you an idea about how close we are. We're not close to anything.
Yeah? Well, we've established that physics or you cannot prove anything to absolute certainty. But the way that I see it is that there has to be something absolutely certain given for it to evolve. If a theory is absolutely incorrect or cannot be proven absolutely correct, at least at the basic level, then how could there be room for improvement? Or how could any of this improvement be credible if even the simple basics of physics or any other natural science is questionable at all times?
No, you have a process for this, in fact. Let's not be very pessimistic about it. We have a process to validate a theory. As Mr. Roger was pinpointing that, of course, we have some types of unfortunate bias in this. But when you come with a theory, you don't go and claim it on the roofs. You have to present it in front of your peers in the scientific community that are established scientists, and then they have to check if it fits what was already here and if it can be accepted. So let's not really be very pessimistic about the process. It has a margin of error, but you have a way of validate, what's scientific and what's not scientific.
But how can you validate it if it can't be absolute? How can you validate something if it can't be referred to from a reference which is absolutely certain?
نرجع كلمة validate again and again. Validate based on what you already know, with no absolute certainty, and what you will discover with no absolute certainty also. Yes?
You said that a single truth is that everything changes, and everything is susceptible to change. But what if this truth changes and will no longer be true? So that would be in itself paradoxical.
No, then we'll have to reevaluate what I was just telling you.
So it will no longer be.
One characteristic of a scientist is to have an open-mindedness. This is one characteristic of IB also. If you're going to show me something that's going to make me review my stance, I will do it with pleasure, of course. Till now, with the instruments we have, with the tools we have, and with our five senses, we cannot but see that everything is in a continuous state of change. You see? Then, if they invent an instrument that's going to show that something is not changing at all, then, of course, we have to reevaluate.
Sir, you previously said that science is a tool in which we are able to understand things that happen around us. It's simply a way of understanding things that already exist in nature. So do you consider a scientist that has made something, that has, let's say, formed a model like Thomson? Is he an inventor? Did he invent anything, or is he simply a scientist that came up with a model about something?
He invented a model. He did not invent something that is a part of life. I mean, let's say you're talking about, for example, again, this model of the atom. The atom is here. يعني رح أقولها بالعربي مع جميلته لتومسون أم بلا جميلته. The atom is here. So, sorry? Yeah. So the atom is here. What did Thomson do? He came up with a model. He invented, you can call it inventor. He invented a model. He didn't invent the atom.
So what makes a normal human being different than, so what makes a standard human, a student, any other person different than a scientist if they don't come up with anything new?
The curiosity is a common factor. The curiosity, I mean, in general, scientists are really more curious to explain than others. I think this is one factor. And perseverance. Because when you want to come with a model, you don't come with a model, you dream about it, and you may dream about it, but then you have to work to put it on paper, we need to refine it. So I think this is the main thing. And in general, they have a really strong intuition. In general. Anyone did not speak till now, then or would like to speak?
Actually,
it's not a question, it's an explanation or another way of stating your question. You're questioning how can a scientist know, okay? Or what differentiates a normal human being from a scientist? Yes. What differentiates a normal human being, the all normal human beings to me, from an artist? To you, an artist, how do you define an artist? Creative. What does creativity mean? How do you define creativity? How do you categorize people as creative or not?
Has the ability to
Is there
express.
a way to measure creativity?
No.
So what is creativity to you?
The ability.
There are certain standards set.
Like?
New thoughts, new ways of thinking, new ways of applying, new uses of whatever is present. These are standards that have been used throughout the ages to create art in the sense of literature, in the sense of visual arts, in the sense of music. It's the creativity in the innovation, of the use and the application of previous methods or the coming up with new methods.
You have standards.
So in other words, who sets those standards?
The personal standards.
So they differ from one person to another, right? So to me, you can say this is a creative way of setting this offer or this facility. Somebody else, it might be very ordinary or very external. So it's relative. So this is what Mr. Oscar is speaking about. They're called natural sciences, right? So that basically, as Mr. Oscar said, everything is there. We're just trying to find explanation to what is there. We're trying to make connections, find out patterns. Creativity is actually someone who's described as a creative person is anyone who can come up with a pattern that is not seen by some other person. Because you didn't see that pattern, you think, or you would describe that person as creative. Yes or no? To you, oh, he's creative, he found out this or he came up with this idea. But the pattern is there, it's who perceives it. And this is where human nature, human characteristics, it goes back to the human being and himself as an individual, as a unique person, right? Because each individual is a unique person. True?
This is what also differs science from the
Exactly.
earth.
They see things sometimes which other people do not see, out of curiosity, out of intuition, out of whatever.
Yeah, it's also like
Experience, life experiences, etc.
it's sort of like in art. If there was no Shakespeare, there wouldn't be any Hamlet, any Romeo and Juliet. But in science, there is present. It just takes a matter of time to be aware of, for us to be aware of.
Yeah, but Shakespeare, that doesn't have to be Hamlet. It could be something else. If there's no Hamlet, there's another author who wrote something else, probably in a different way. It's the same idea, but in a different way.
Anna Quindlen says, every story has already been told. There's no story that you can write that hasn't been told before. So if there were no Shakespeare, you wouldn't have Hamlet, but you would have had a story that is similar to Hamlet's story. What makes a writer and why we still write is because the way you write it, the style in which you present it, and the ideas that you embed in it would differ from the other author, from the other writer, from all the stories that have been told.
Yes?
Sir, you said that, let's say, you spoke about atoms. You spoke about atoms. And you said that they're there, you just don't know how to see them and how to model them, how they look. But don't you need a proof for something to say that it exists? So if we only have ideas about how it looks, don't really have a proof that it's actually there, then how
Again, you have to look at the history. It's not that. So the first idea about in general when they started thinking about atoms were people who really like to divide things. So we divide this, it's getting smaller. And the main idea came, can I keep on dividing till infinity or will I have to stop at a point? So this was an original question.
But do you have a proof that you can stop at a certain point?
Okay. So later on they said that the atom is the smallest one, okay? Then they said, but just to answer your question about the nucleus, we did not see a nucleus, but we're sure there's a nucleus.
What's the proof?
We should.
How can you say
Rutherford experiment.
There's evidence.
Yeah.
You know, this might
The Rutherford experiment, then I need time to explain it. I'm not going to do this now. I don't have too much time. But there is, a certain evidence about this. Then they said, oh, the electrons is the smallest particle. And then again, oh, no, we have, the leptons, the hadrons, and the bosons. So now they are taken to be the smallest. Later on, we see what happens. It's a thrill. I will بس أنا بدي أخلص sorry. I'm going to end لأنه anyway just for you the main idea about science, and I like it very much. Richard Feynman says, I really invite you to watch his YouTube on videos because he's one of the rare persons who are a mixture of creativity and of analysis. Outstanding. He has talks about beauty, about honors, about things that are not completely scientific, although I don't like to categorize like this. So Feynman was asked about what is science. he said that science is like you're peeling the layers of an onion. So you peel the first layer, and you discover another one. It doesn't mean that the characteristics of the first layer are to be thrown away. And you can keep on peeling, and as it concerns our search, we may continue peeling till infinity. But it doesn't make me scared. I'm quoting him, it's not me. It doesn't make me scared that the universe is so unlimited and so infinite, because it gives me a sense of wonder, and with no sense of wonder, we cannot live life to the fullest. This is the idea that I have about anything that we encounter in life, beginning from sciences. Yes?
Experiments that were done at a certain time period were able to prove a theory right. However, after evaluation and further experimentation, it was claimed false. Then how is it possible that the primary experiments were functioning properly, although they were incorrect?
No, it's not. Again, I give the example of Newton's. I agree completely that some experiments were performed wrong, because maybe the people performing them were not up to the level we have, or the tools. We have this in the history of science. Yes, again, it's a continuous evaluation process. Some others were not wrong. This is where I like to clarify. Newton's second law is completely correct, but at the macroscopic level. So within limits. Exactly. It doesn't apply everywhere. So what was wrong is our idea of saying that Newton's second law is explaining all motions that we encounter in the universe. It's completely wrong, because it wasn't able to explain the motion of subatomic particles. You see?
So the development allows
Technological development
allows us to extend our five senses that you were talking about in the beginning, about not being able to see that the star might have been dead, and we are seeing the light that is just shining, not the actual star. So technology allows us to see the incorrect.
To clarify things. Yeah, and it comes also with its burden. Technology, this is another topic. It comes with a burden. Nothing comes for free. Matter, antimatter, everything comes with its opposite.
We will try and end this today, because we're almost out of time. With Ms. Lady, she has something to say, and that will be the end of it for today.
Continuation. As Mr. Kuska was saying, it's not a matter of being wrong. It's a matter of getting or trying to explain what's happening around. Okay? And what we have arrived to today is an accumulation over all those centuries. Okay? And it wasn't done overnight. So we shouldn't always, this is why we always mention what happened throughout history. Just because it was modified or changed or discarded, we forget about it, because this is a build-on. So it's important to know how it was arrived to, and so to avoid wasting time or going through the same way. Technology is an important thing, but we as a generation in 2015 compared to the generation in 1960s, let's say, or in the 1800s, we are benefiting from a lot of knowledge, more technological advances, and nowadays we are using more of our brain. And as the humans evolve also, they're using some brain research. And this is another question for you. How much are we using of our intelligence or our brain cells? So if with the new or in future centuries, probably not just decades or whatever, okay, millenniums even, you have to go to the level of the brain development and the usage of the brain of human beings, and then you can see whether they come up with new things in which sense, new explanations, not discovered new things. Because as Mr. Oscar said, when there is nature, and they're called natural sciences, not invented. Thank you.
Thank you.